Hi, and welcome back to day 5 of week 3, where we've been talking about circles. And I want to thank you if you've been here for all 5 days. If not, you might want to go back and check that out. Circles is very important. Okay, it's area and perimeter. It's circumference, excuse me. Very important that you understand it. Pretty much introduced to you here in the 6th grade, so very important that you look it over and make sure you understand it. But today we're going to do problem of the day, so it's going to be a little bit of an enrichment activity, and today will be a little bit more of a challenging day. Okay. So today we're going to focus on 6.7b. We're going to solve problems, including practical problems involving circumference and area of a circle. Okay, so we're really going to tackle that today, right? But what I want you to do, okay, right now, is I want you to try and answer this question, okay, because it kind of sets the precedent for how we're going to go about doing our activity in the end, right? But I want you to pause the video and see if you can fill out this drag chart, okay, and then hit play, and we'll be able to see if you did it correctly. All right, so I'll check in with you in a few moments. All right, so coming back here, all right, we're gonna fill in our drag chart here based on our word problem. All right, so let's read it. Okay, so what is the diameter of a circle with a circumference of 87.96 miles? So here it's a little different because in previous examples we were told what is the diameter or the radius. Well, this time it's given us the circumference off the top. So we're gonna put our number 87.96 right here in this section here. Okay, 87.96. All right, so I'm gonna fill that in here. 87.96, and it was miles, so I'm gonna put MI here. Okay, now how in the world are we going to use this information to figure out the rest? Well, what do we know about circumference? Circumference is pi times the diameter. Okay, so that 87.96, right? Circumference is equal to pi times the diameter. Well, we know what the circumference is, right? It's 87.96. So here we're kind of almost like working backwards now. 87.96 is equal to pi times the diameter. So we need to solve for this diameter, okay? This is being multiplied by pi, okay? So all we got to do to isolate this variable to get the d all by itself, the diameter all by itself, you have to use inverse operations, right? So the opposite of multiplying by pi is dividing by pi. And what you do to one side of an equation, you have to do to the other side of an equation, right? And we know this is 3.14, but the same number divided by itself, it equals 1, right? But we're not going to write 1d here. We're just going to put the letter d. All right, so the diameter is going to equal 87.96 divided by pi. All right, so let's go to our Desmos then. All right, 87.96 divided by pi. 87.96 divided by pi. And there we see we got 27.9985. It's definitely telling us to round up. So 27.99, that 99 is going to round up to the next whole number. So our diameter is 28.00. In other words, it's 28. So here I'm going to write the number 28. And again, units is important, miles. Okay. Now, if the diameter is 28, what's the radius? Well, the radius is half the diameter. Half of the diameter. In other words, 28 divided by 2. Well, what is 28 divided by 2? 28 divided by 2 is 14. So our radius is 14 miles. Now, what is the area? Well, we know the area formula, the equation tells us to multiply pi times the radius squared. So the area is going to equal pi times the radius squared. Well, what is the radius? The radius is right here. The radius is 14. Okay, so it's pi times 14 squared. So we're going to go ahead and check on decimals again. Let's clear that. Pi times 14 squared. Pi times 14 squared. And here we see it's 615.752. So the 2 is going to tell us to keep the 5 as it is. So it's 615.75. 615.75. All right. And that is going to be in square miles. That's kind of big. Let me make sure it fits. 615.75. 615.75, and that's miles squared, right? Square miles. Okay, so that's that. All right, that is our opening exercise. Okay, so what I want to do now is take it a step further. All right, because we kind of had to think backwards there. Okay, and that's kind of what we're going to be doing for today's lesson. All right, so let's take a look at what I'm talking about here. Okay, so let's look at this question. Okay, it reads, if the radius of the bullseye section is 7 centimeters, how much area on the target is not bullseye? All right, so again, this is available on RPS at home. There's a worksheet there that kind of lays all this out. But again, if you have a sheet of paper and a pencil, you're good to go. Just draw yourself a little chart, a little DRAC chart, right? We're going to first look at the whole target, then the bullseye target, and then we're going to try and think about what is the answer, okay? So let's use cubes, okay? If you remember, cubes was our day 4 strategy for solving problems. In cubes, the C stands for circle the number, so I'm going to circle the 7. All right, and then the U in cube stands for underline the question. The question here is, how much area on the target is not bullseye? Okay, and then we're going to box the keyword. In this case, it tells us straight up. We're talking about area here. Okay, and so we're going to need to know what the radius is for the whole target, right? Here's our whole target here. All right, we see that we have a 120. We got to figure out what that's talking about, filling in the chart, and then using our chart to answer our question. Okay, so let's go through it. All right, so first of all, the whole target we're going to start off with, okay, since it's the first one here. What is the 120 representing here? Where does that 120 go on our chart? Is it under the D, the R, the A, or the C? Well, this 120, it goes from one end of the circle to the other end of the circle. It's just a straight measurement. That right there, ladies and gentlemen, is the diameter. Okay, so I'm going to put that 120 centimeters, all right, for the target of, uh, um, we can say it's for archery in this case here. All right, 120 is our diameter. So what is the radius? The radius is half of that, half of the diameter, right? One half of the diameter. In other words, it's 120 divided by 2. What is 120 divided by 2? Well, if you get your calculator out, you'll see that 120, the diameter divided by 2, it equals 60. So it's 60 centimeters. Okay, now let's talk about the area. Now, the area is pi times the radius squared. So this radius is going to be multiplied by pi, and it's going to be squared. Okay, so pi times the radius 60 squared. So we're going to, again, use our decimals. Very important that we're using that. Okay, guys, because first of all, it's even better than the TIs that we tend to use, right? Decimals does the calculation for you here, but this is going to be pi times the radius squared, pi times 60 squared. So let's do it. All right, so we got our pi button times 60 squared, and here we see it is 11,309.73355. So after the 3 is a 3, which means it's going to remain. We're going to round everything to the hundredths again. That's the way we've been doing it all week. Not always the case, but that's what we're going to stick with just to keep it simple here. So 11,309.73. 11,309.73. 11,309.73, and that is centimeters squared. Okay, let me just double check that. 11,309.73. Good. All right, I'm gonna shrink that down so it could fit in our box here. Okay, now I'm not going to calculate the circumference because we know for sure this is our area, but it's a really good practice to just know how to calculate your circumference. We know our circumference is just pi times the diameter, pi times the 120. Okay, but let's think about the bullseye target. Now, what do we know about the bullseye section of the target? Well, the bullseye section, the radius, it says here, the radius is 7 centimeters. So we're going to come back here and we're going to put the 7 where it belongs, which is right here. Okay, 7 centimeters. All right, and the area is pi times the 7 squared, right? So here we're going to do pi times 7 squared, the radius squared, pi times 7 squared. So I'm going to go ahead and come back here, right? I'm going to get my 7 here. We're gonna square it. Okay, so it's gonna be pi times the 7 squared. Pi times the 7 squared. All right, so let's do it. All right, so now we're gonna go back to decimals. Pi times 7 squared. So, all right, so let me clear this. Pi times 7 squared is 153.938. The 8 tells us to round it up. So it's 153.94. 153.94. 153.94. Trying to remember. 153.94, and that is centimeters squared. Okay. All right, so now we know how much the area of the whole target is and how much of the area is the bullseye section. So the question is, how much area of the target is not bullseye? Well, if we know that the whole area is 11,309.73 square centimeters, and we know that this tiny little target is 153.94, well, the not would be all of the target minus the little bullseye. In other words, it would be this number, the target of the whole target area, minus the bullseye target area. All right, what is this? 18. Let's make this 19. Let's make it look a little. All right, so we got to subtract this from that, right? So I'm gonna do my little subtraction symbol here. Okay, so when we subtract those guys, we get what? 11,309.73 minus 153.94. Let's clear this. All right, 11,309 point, let me just make sure, 11,309.73 minus 153.94. 153.94, and we get 11,155.79. That's our answer. All right, let me see that again real quick. 11,000, this equals 11,155.79. 155.79. And that is centimeters squared, right? I'm not sure what happened there, but let me try and get a little more room here. Square centimeters, so I got to square it. Very important that we have our units correct, right? This is our answer right here. 11,155.79. Okay? So that was an example of kind of what we're going to be doing today. All right, we're taking it up, right, to the next level. We're picking it up a notch. All right, and we're trying to figure out, well, how does this come into play in real life situations, right? Well, here's our situation for today. All right, so here's our problem of the day. Okay, you are planning a big birthday party. You found a place to rent that has rectangular dimensions. It is 50 feet by 65 feet. The DJ you hire requires 900 square feet for the dance floor. If the circular tables are 12 feet in diameter, what's the maximum number of tables you can have in the room? All right, so this is going to require some real thinking here. Okay, so I want you to pause the video, all right, and I want you to try and think, how can you figure this out given this information? Don't forget about using cubes. All right, so go ahead and do that now. And I'll be back to go over it with you in just a moment. All right, so let's go ahead and do cubes here. All right, we read the problem. All right, cubes tells us to first circle the numbers, So we got 50 feet by 65 feet. We know that it's 900 square feet. All right, we know that the table has a dimension, a diameter of 12. Okay, and what I want to do is use this information, all right, to fill out a DRAC chart and solve it, right? But we know that those are our numbers. We're going to underline the question. Okay, we want to figure out how many tables we need. Okay, we're going to box the keywords here. All right, well, believe it or not, this right here, 50 feet by 65 feet, is very important. Rectangular is also very important. Okay, dance floor, okay, is also very important. Okay, now what does it sound like we're talking about here? Well, if we're talking about the dance floor, we're talking about the space that you're going to need to put tables in. What we're really talking about here is area. Okay, so we're going to break each and every one of these parts down. We're going to talk about the area of the room, the area of the dance floor, and the area of each table. And of course, they're circular. Okay, so the area of the room, all right, it's 50 by 65 feet. 50 by 65. So 50 by 65. What do you think that by stands for in this question? Well, it means that we are multiplying. So a 50 by 65 foot room has a length and a width, base and a height, however you want to look at it. 50 by 65, well, 50 times 65 tells us that the entire room has a space of 3,250. 3,250, and I forgot the units here, feet. So we're talking about square feet. All right, here's what I'm gonna do for this. I'm gonna say SQFT, right? Square feet. All right, area of the dance floor, right? The DJ needs a part of that dance floor, okay? So the dance floor, they gave it to us. It's 900 square feet. All right, so that's space that we lose. All right, 900 square feet. Okay, so that's that. So we got the area of the room, 3,250 square feet. The dance floor, we're gonna lose 900, and then we got to think about, well, what is the area that each table is going to take up? Okay, so we're gonna figure out based on our key information what we know here. It says if the circular tables, excuse me, are 12 feet in diameter. All right, so we know where the 12 goes, right? Where does it go? Right? Hopefully you realize it goes in the DRAC chart under the letter D for diameter, right? Well, for the area, we need the radius, right? Because we're multiplying pi times the radius squared. Well, whoop, if the diameter is 12, what's the radius? Well, we know that the radius is half the diameter. In other words, it's 12 divided by 2. So what is the radius? The radius is 6 feet. Now we can figure out the area. The area is pi times the radius squared. In other words, oh, I keep doing that. It's going to be pi times the radius squared. The radius is 6, and that's going to be squared. So we're going to put the exponent of 2, right? And once again, we're going to use our Desmos calculator to find that area. So we got our pi now. Pi times 6 squared. All right, so let's go use our Desmos calculator. Pi times 6 squared. So I'm going to clear that out. Get my pi button. Pi times, was it 6? Yeah. 6 squared. And there we see is 113.097. So again, we're rounding to the hundreds. That 9 has to go up. So instead of 9 hundredths, it's going to be 10 hundredths. 113.10 is our area. 113.10 square feet for each table. Okay, so these are the numbers that we got to take into account. We know that the whole room is that amount, 3,250. Okay, we know that the dance floor is going to take up part of that whole room. It's going to take up 900 square feet. And then we know we're trying to figure out, well, how many tables are we going to use? Well, each table is 110 square feet. So think about it. How are we going to figure out how many tables can fit in here? Well, let's first of all talk about how much space we're going to need, right, for the tables, right? Because we know this is the total, but we're losing 900. In other words, we're subtracting 900 from this amount. So that 3,250 is going to be subtracted by 900. So 3,250 minus 900 square feet gives us what? Because that's going to be the amount of space we have for the tables. Okay. 113, I'm sorry, we subtract that, 3,250 minus 900. All right, let's do that. 3,250 minus 900. And there we see it's 2,350. Okay, 2,350. So we got 2,350 square feet to play with. SQT. Let me shrink this down a little bit. All right, now, does that mean we could fit one table, two tables? What do you think? Each table is this amount, right? To give you an idea of what that may look like, right? Here's a picture of the whole entire room, right? And the dance floor takes up a certain amount of space, doesn't matter really where we put this, right? But that's 900 square feet, okay? How many tables are we going to get to fit in this remaining space, right? So if we're talking about how many can fit, how many of these, how many 113.10s can fit into 2,350 square feet, what are we talking about here? What's our operation? What do you think? We know we got to use this, right? How many 2,350s, I'm sorry, how many 113.10s can we fit into 2,350 square feet? You know what we're talking about here? Not subtraction, okay? Because if you just take away that space, there's a whole lot more room there that will still fit another 113.10. All right, what we're talking about, something I'm trying to draw, we're talking about what? You probably know it now. Yeah, we're talking about division, okay? We got to figure out how many tables can fit into that space. All right, so if we get our calculator, all right, and we do the division, all right. Let's see what we come up with. 2,350 divided by 113 and 10. 2,350 divided by 113.10. And there you see we got space for 20.77 tables, right? If you wanted to round it up, you could say 21. Actually, we shouldn't round up because there's no such thing as 77 hundredths of a table. So we got room for 20 tables, okay? Now, that is if, let's put the number there, 20.77 tables, okay? Now, that is if it fits perfectly and takes up every single space, all right? Every single amount of it. But as we know, when it comes to circles, okay, it doesn't cover everything perfectly, right? So what I want to do is I want you to get a piece of paper, all right, and I want you to see if you can figure out, right, if you were to take a piece of paper, all right, and lay out the tables, right, right, you know that in a party, they're not gonna really be put like this, right? Nobody sits like that. You would probably need some space here in between, all right? I want you to get an 8.5 by 11 paper, right? Let's say the long length of the paper is 65 feet. The high length of the paper is 50 feet, right? And then break a section off, right? What you're going to do is you're going to do 3/5 of it going this way, right? Just, take out a section and that will be your 900. Let's say it's a 30 by 30, right? Not quite halfway there, a little less than halfway of the length and 3/5 the width of the dance floor, right? And I want you to draw a picture of it, right? And I want you to email it to me, right? At jespinal at rvaschools.net. All right, and I want you to tell me, what did your layout look like, right? As far as fitting the tables for the party, right? You want to try and get as many tables as possible to fit into this space, all right? Maybe you want the dance floor over here. Maybe you want it in the middle. I don't know, okay? But we know we got space, right, for 21 tables. But as we know, tables don't cover floors perfectly, right? Circular tables. All right, so I want you to draw a picture, and in your picture, I want you to show me, all right, what is your breakdown? What does it look like? How many tables did you use? All right, and then email it to me. Let me put my email up again. All right, it's at jespinal at rvaschools.net. And let me see, what is your party looking at? You want to try and maximize. You want to have as many tables as possible, okay? jespinal at rvaschools.net. Email it to me there, all right, so I could take a look at it, see how you did. All right, but this concludes our week involving circles, okay? I hope you enjoyed it, and I hope you learned something from it. You can also email me at this email address, and I could help answer any questions if you have any trouble with what we did today or what we've done for the week. All right, so talk to you later, and remember to stay active.